Okay, any other? Yeah.
Just looking for some new, fresh perspectives in automated testing of web applications.
Okay, okay. So I'll forewarn you, I'm not going to focus a whole lot on the Selenium aspect, so hopefully it doesn't dash your hopes here. More focusing on just taking web performance analysis and kind of automating it using open source tools. Maybe there's something useful here for you. That said, the question to start with why performance? Why is it important to worry about performance? And it turns out some big names have done a little bit of research on that question. People like Bing found out that to make their pages 2 seconds slower, they saw a 4.3% drop in the amount of revenue they got per user. These aren't large time deltas, but at scale they make a big difference. Google found that by adding about half a second of delay to their pages, they saw about a 0.5% drop in the number of searches per user. So again, you look at what your business metrics are, and then take your performance data and ask yourself, what impact does my performance data have on my business metrics, on the bottom line basis. Yahoo again, 5 to 9% drop in full page traffic. These ones on the e-commerce side are kind of interesting. Shopzilla, by a 5-second speed up, they saw a 7 to 12% increase in conversion. Edmunds, again, 3% increase in ad revenue. So the question I want you to ask yourself is, what are your key business metrics that you're trying to drive with your website or your web app? And then what kind of impact will performance have on those? In the community, just here's a list of individuals you can follow. I'll have these slides up. The last slide will show the slides if you're interested. Just some people in the community to follow that have lots of good insights on these things. Steve Sauer is probably kind of the lead guy in the community. Wrote these 2 books. He originally worked for Yahoo, developed a tool called YSlow. Now works for Google. Stoyan works for Yahoo. That's the SlideShare link there. He gave a talk at the O'Reilly Velocity Conference a few years ago called The Psychology of Performance. It kind of talks about how we're wired, how people are wired, and how that relates to website performance. Ultimately, you're really trying to target about 2 seconds for a page load time on the web. And anything longer than that, people start to lose attention, you start to mix up their workflow, and really that's kind of the sweet spot you're trying to target. But then again, there's a lot of things you can do to kind of help people, like if they're anticipating something, maybe throw in something to help them while they're waiting for something to happen. It's just a really good talk to watch. Joshua Bixby, you've done the mailing list for Strange Loop Networks. Of course, they're trying to sell you their product, but they do have a lot of good research that they do about web performance. Andy Gowdy is an ex-DoubleClick executive who started a company called Cashpoint. He's got a lot of good ideas. Really nice guy. Pat Comedian developed a tool called Web Page Test that we'll take a look at. How many of you here are familiar with Web Page Test, by the way? Oh, good. Maybe something new. Good. Very useful. And then, of course, if you have a chance, convince your boss to go to the O'Reilly Velocity Conference. It's a fantastic venue. Where it's pretty much focused on this, plus web operations in general. So you get a lot of stuff about configuration management, stuff that kind of thing. You get a lot of big companies in the field presenting, and just more than anything, it's a great place to go rub shoulders with some really smart people. And then Sergey, who does the New York Web Performance Meetup, he also has some good stuff on his blog and the tweets. And then I've got a list, a Twitter list, that kind of summarizes a lot of those if I'm just follow that. In the commercial side of things, there's the usual suspects: Keon, Gomez, Cashpoint, Webmetrics, Strange Loop, Ninebase, et cetera, et cetera. There's probably a bunch here that I left out that is, insert your favorite performance vendor. Oh, one note on SmartBear, they also own AlertSite, which is a monitoring company. But they have a tool called LoadUI if you're looking to do load testing. Load testing from some of these vendors can get very expensive really fast. And what LoadUI is, it's an open source tool. They have a professional version that you can pay for, but the basic version works really well. And you can spin up load generation in the cloud. So you can take an image that they have, put it in the cloud, and spin up load testing for different kinds of loads. It's really back, and really quite a nice tool. So in our web performance toolbox, how many of you are familiar with YSlow? Okay, quite a few, yeah. So YSlow is a Firefox plugin that you run your page in there, and it will. Let me back up one step. How many of you are familiar with the Firebug plugin for Firefox? Yes, about everybody. Okay, so if you're familiar with the net panel, you can see all that. So anyways, YSlow analyzes the data that comes out of the net panel in Firebug and gives you a bunch of recommendations as to what you can do to your website that will help its performance. And it's based on the principles in Steve Soutter's book, the high performance websites. He's got a number of principles, a number of things that you ought to look at in improving your website performance, probably which were covered in the session, one of the sessions previous to this, about website performance. Google PageSpeed is very similar, comes from Google, has a number of other recommendations that you can follow. Web page test, we'll look at that. Harviewer is another way to visualize website performance, we'll look at that. Again, the Firebug net panel, Chrome developer tool, Control-Shift-I, the net panel in Chrome. Using IE, you can use Fiddler, which is a performance monitoring proxy that you run on your machine. And HTTP Watch, I'll mention that, it's not free, it's not open source, but it's a very good tool. It's a little expensive, but really good. So let's look at webpagetest.org for a minute here. And I'm going through this stuff kind of as to give you an idea of what the tools are and what we're going to, the data we're going to be looking at, and then we'll talk about how we automate all that. So web page test is a tool that was developed originally at AOL, and it's very kind of similar to YSlow in that we provide recommendations on what to do to improve website performance. But let's have a look at, so you type in the site you want to look at, you can choose a spot in which browser, so people have these agents running around the world in different places. So let's just look at actually Beijing, kind of fun. I used to have one in China. I did a lot of research about performance out of China, so that's quite interesting to me. And IE7, okay, that works. If there are different connections available, you can choose what kind of connection speed you want to run it from. One test, we want to do both a first view and a repeat view. When you're doing performance analysis, it's important to look at what did your page load on an empty browser cache, and after that first load, then what does it look like after a repeat load? Because that's going to make a big difference depending on how well you have your objects cacheable, the kind of headers that you're outputting that make your content cacheable. So first view and repeat view will show you that difference. If you don't want the rest of the world to be able to see what you're testing, keep your test private. You have some other stuff you can do. Stop your test, document complete, don't wait for like background calls or other rendering to keep on going. Ignore cert errors, capture network packet trace, there's a number of other things. If you have authentication get in there, you can do that. There's some scripting you can do. Block ads if you want to block requests containing certain URLs that you don't care about, maybe third-party content. If you want to capture a video of your page loading, they've got some nice tools for that. It takes a little bit longer. So anyways, let's do that.
Does it actually run IE7 over there? And
Yeah. So they've got somebody's got IE7 running. So there you go. Actually, it's really interesting. Talking about browser versions in China, if you're trying to do anything in China, while the rest of the world has pretty much ditched IE6, you'll find a huge contingent of IE6 still in China. So if you're designing for China, keep that in mind. Much as we hate that, right? yeah, it's just something to keep in mind if you're trying to target the market.
China
Since
where did the control better?
And it'll take a few minutes to run this. And kind of the other reason why I wanted to show you web page test is to get you familiar with the idea of waterfall charts. How many of you are familiar with waterfall charts? Okay, they're a really useful tool in looking at the performance of a web page. And hopefully by choosing one in China, this isn't going to take really, really long. It's always hits me as ironic when performance tools take a long time. Right. How many of you are developers? Sysadmins? Students? Other? Okay. What are the others? QA, okay, cool. Yeah, okay. Okay, so we've got one run. Did I not need to repeat you? You did. You did it. So anyways, while we're waiting for that, let's wait for the person to have a look at this first view. Okay, so up here at the top, you'll notice it's got a number of suggestions, things like, what's your first byte time, people I've enabled. And so it'll tell you how well you're doing, give you a little letter score, and how well you're doing in those particular things. Some summary information up here at the top. We're going to focus right now kind of on the waterfall chart. So what this is showing you is this is showing every component that makes up your page. You've got the index, the base index page, and then every object that it refers to. So every object that the browser had to load as it was rendering that page, it shows you the timing components for each of those objects. So starting out here with the root object, better point here, and then you have a key up here at the top that tells you what the component time is made of. Now every one of those requests has to do a certain thing right. So you have to make your connection. Actually, first you have to do a DNS lookup. That's going to take time, depending on whether your local DNS resolver has the entry in cache, or if it has to go out and refresh that. If your local resolver has to do the recursive lookup to get that information. So in this case, it looked like it had to do a lookup. So we had, and then below here you can see they have a tabular representation that tells you it took 1.2 seconds to do the DNS lookup. Wow. It's kind of crazy, but that's China, right? Okay, so not too surprising. Especially if your DNS servers are not anycasted and if they're not geographically close. And that's probably key takeaway here is if you're trying to improve the speed of your website in certain geographies, the most important thing you can do is get your content close to that geography. There's nothing like the speed of light. Okay? So it's a constant you just have to deal with. So things like using CDNs to get your stuff closer, just putting your content on the Amazon cloud nodes that are closer to where your users are. That will go a huge way. So anyways, you can see here almost 1.5 seconds we're taking on the DNS request just for that index page. And then you have to set up the TCP connection between them. And then you have to send that request across the thing, and then you have to wait for that first byte to come back. So we sent the request, the server on the back end is doing whatever it does to generate and render the page. And that's your kind of first byte, and then you've got a content download. So this green line here is what's called start render. That's another important thing to keep in mind is that different browsers will behave differently as to when they can start rendering the page. Some of them, depending on how you're calling your JavaScript, will block until they have all the JavaScript they need to be able to parse and then render your page. So if you can fetch your JavaScript asynchronously, maybe on the side or in a background request or something like that, then the browser can start rendering things before it has to. So that's what this green line here is telling us is when the browser is able to start rendering. And then here, document complete over here is this blue line, which in China, 10 seconds to load the UTOSC conference website. I'm not sure how many people in China are trying to, 10 seconds, yeah. So, and again, there's a lot of factors that go into play there. Number one, how far they're away, which is obviously a great geographical distance. Number two, what kind of network connection are they on? Number three, particularly in China, during peak times, international network congestion is terrible. Okay, if you're trying to serve content out of China during peak times, and you're serving it from the United States or anywhere outside of China, it's going to hurt. Let's see here. So then you've got your style sheets, using JavaScripts, and it's all the same kind of information. For every one of those, you've got to, for most of these, since it's all in the same domain, you're not going to have to do your DNS lookup that's already got in cache in the local browser cache. So your browser has a DNS cache inside as well as your local resolver as well. We got a Gravatar that had to do a DNS lookup on that guy. Oh, and then you had some problems with these guys.
Google API.
And then down here it shows you what the CPU utilization looked like, which can have an impact on the way for rendering. If it has really intensive JavaScript, that will kind of be flagged there. Bandwidth down here, how much bandwidth it was taking up. And then they have a chart that does it by connection. So we had to make a connection to conference.uts.org, some Google fonts, Google user content, some Gravatar stuff, and then the type of content down here. So anyways, just a really good tool, but mainly I wanted to show you that just to get used to this idea of the waterfall chart. It's probably your #1 tool in analyzing the web
So in this case, would you look at that register dash now pane?
Oh, yeah,
So
absolutely.
huge.
Yeah, you want to look, okay, look at, yeah, you want to look at, what size is it? Come down here in this
Nice.
table, register now, ping, where's that guy right here? It's only 34K, so, what happened?
Just snagged.
Maybe it's a fluke, maybe, that packet hit the firewall or something. So, there's questions you got to answer right there. Another interesting thing to look at is to know when the page was able to render. We had to fetch all this JavaScript and style sheet, and once we got to this point, once we had that on the anyways, you can sometimes see things line up. And this has also helped you to see how parallelizable your site is. Given that this site is mostly all in one domain, the browser usually can't parallelize that. So your browser will open up multiple connections, and different browsers have a different number of connections. And so sometimes you'll see things lining up, like these three lined up, so the browser is able to fetch those in parallel, right? So sometimes one of the recommendations is add more domains to your site. So maybe you have an images domain, maybe you have a style sheets domain, up to a certain threshold. After a certain threshold, you kind of lose some of the benefit. I think the sweet spot's around 4 or so. So anyway, it's just something to think about. Okay.
Would Mod Speedy help with that? Or
What's that?
Would Mod Speedy help, where you can start downloading all 10 things on one socket on your?
I'm not super familiar with ModSpeed. Is that Google's Speedy protocol?
SP, I think it's pronounced Speedy.
SPDY?
Speedy.
Yeah.
Yeah, I'm not super familiar with that.
And instead of the waterfall being all, it would just be,
Yeah, yeah. You can
Or-
work on it, yeah.
you can get them all parallel.
All right.
Only
so
works
back
for
to the
Chrome
rotation
and
here. So that's what makes this.
Firefox 13.
10, 13.
Okay, and then
13 would be
Firebug,
on the
Wise Flow is
default.
very similar.
It's
Same
in it right
Chrome
now.
network. I want to do
Since
demos
10 or
on
11.
those because of time. Similar story with the HTTP Watch and Fiddler if you're interested in doing it with ID.
IE7.
Okay, so now let's talk about how we're going to automate this. Okay, we want to be able to do this, and you can go through performance improvement efforts and have a big push. We're going to make our website fast, but you have to keep an eye on it over time, because over time, a lot of people and everything starts kind of slowing down again. You're adding more content to your website, and you have to start. You have to keep an eye on it. So what hopefully, you can do with this stack is keep an eye on this over the long term, just to see how performance is running. So the goals we want to have. We want to define a transaction that's a representative sample of activity on our website. Maybe go to a login page, log in, run a report, or something like that, right? So we want to be able to automate, capture that transaction, first of all. We want to automate that. We want to export the data that we get from that in some meaningful and portable form. We want to then process the data if we have to, and then make it available for analysis and visualization. You can do a lot of this with commercial tools like Keynote and doing this. But in a lot of ways, they lack a lot of flexibility that you can get with some of the open source tools we'll talk about today. And it's actually pretty easy to do with the open source tool. So again, here's our task. This is what we'll spend the rest of the talk going over. We're going to record and capture web traffic action with Selenium. And I apologize to those who want more detail on Selenium. We're going to be really pretty superficial. We want to play it back repeatedly, but hopefully I might give you some pointers, some things we can look at. There's things that you could look at going down the road. We want to export the results in HAR format. We'll talk more about that using Firebug and NetExport plugin. We're going to optionally introduce some artificial network latency. If you want to see what it's the difference in timing to have your site running maybe in a different host, a web host, it's going to add 10 milliseconds of latency or something like that. You can simulate that using Linux with netem. Then we want to extract summary data from the data that we've collected and prepare it for analysis. We're going to use Perl and shell script to do that, and we're going to analyze and visualize the data using R. So start out if you want to figure out how we're going to record the transaction. So we'll use Selenium IDE. It's a really simple tool. Let's see, let's run over here to Firefox. It's just an add-on that you can install here. How many of you are familiar with Selenium IDE? Most, a lot of you are. Okay. So basically, you have a starting page. Let's add a new test case called Untitled2. You give it a base URL. We say it's conference.utos.org. Put it into record mode. And let's come over here. Let's load up the page. And then we'll do a few clicks. Another base page. Okay, as long as it keeps working. Interesting to see performance analysis of using this thing. Okay, so you click over here, and Okay, then you see we had an open event and a quick way, so we click the link about, click on the volunteer link. And then we saw another one, we click on that link. So we're just creating different events to come along. It records a transaction for you so you can then replay it.
So then,
Yeah.
since I don't know Selenium, can you then type in a username and password?
Oh, yeah, absolutely. We'll capture that for you, yeah. So at Adobe, when I use this, I wanted to simulate the transaction of logging into our application site demos. And so I had the transaction, went to the opening page, typed in the login credentials, went to the resulting page, I clicked the thing to select a different product, and then it created to run a report. And so to record all those steps that you're doing. And what I understand, though, from talking to someone in one of the other presentations was that sometimes Selenium falls down with dealing with AJAX requests or batches.
Yeah, it's pretty terrible.
Okay, so one thing I'll suggest to have a look at is something called WebDriver. You guys familiar with that? Is that any better?
I haven't really heard about it. I haven't investigated.
Okay, so have a look at WebDriver. It's supposedly a different way of interacting with the browser instead of just through JavaScript like the normal Selenium does. Is it actually drives the browser APIs themselves, so you're interacting directly with the browser. But hopefully it abstracts things so it's still just, okay, click on this link, look for this text, that kind of stuff. So have a look at WebDriver, it looks really interesting. I won't cover it in too much depth here. So anyways, we've got our thing here. Stop recording, and then let's export the test case as. And you have this wonderful array of languages that you can export your testing to. I'm a Perl guy, so I'm going to export it to Perl. And let's see what settings down here in the downloads folder. UTOSC, and call it yeah. Okay. There, come over to our consider. So you got this guy. And end up the script looks like this. So whatever client you're going to end up running the script on, you're going to want to have the test Selenium Perl module installed. There are different language bindings for a lot of different languages. So you just got to have the right kind of module installed in the machine where you're doing this work. Yeah,
Are you using Strawberry Perl?
I'm not.
Are you using the X one?
You mean on Windows? Oh, no, actually I didn't run this on Windows.
Oh, okay.
I ran this on a Linux machine. So I generated on the Linux machine. Did generate the script on the Linux machine.
Okay. I'm just curious.
Okay, so, and then you got to make sure you have these other dependencies in place. This line here, these 4 lines are going to point to the Selenium server. Selenium server is a Java app that runs, listens for these requests, and when it receives a request, it opens up a browser on the local machine where it's running and runs through this script, drives the browser. WebDriver is similar to that. And so with WebDriver, you may not even need the Selenium server. You can just interact directly with WebDriver. But I believe the Selenium server can also drive WebDriver to do remote or something like that. You may need to adjust this guy depending on what browser you're trying to drive. But then it just, opens up / starting with your base URL here. Click on this link, give it this amount of time to wait for the onload event, and so forth. Pretty straightforward. Okay, so let's go back to this. So anyways, you end up with the script. We already saw this. That's what you get. So now we need to replay that back repeatedly. So you install, of course, the modules that you need on the box where that's going to run. You want to install Firefox. In the case I use Firefox. You want to create a clean Firefox profile. Because you don't want, the profile that's got all of your add-ons and might introduce artificial latency. Or maybe you do, right? Maybe your users are savvy, they're going to have 5 or 10 add-ons installed. Who knows? It depends on what you want to do. Start Firefox with -P, and it'll pop up Profile Manager, and you can create the profile that you want to use. So you'll need a JVM to run the Selenium server. I'll let you know DCJ Java did not work for me, so you want to grab like OpenJDK or something like that. Download the server from this page. This is the invocation that I use. You call Java, give it a jar file. The server is just a jar file. It's really easy to work with. Whatever version you happen to get. And then you pass in this option, Firefox profile template. And you point it to the profile that you just created. Okay. And something, okay, we'll talk about that later. So you're going to run your Selenium script, which references this server. So whatever port you have to be running it on, like we saw in the back in here, we're going to be pointing to whatever host your Selenium server is running on the port. So Selenium will open Firefox with that clean profile. It'll run that transaction, then you can really just automate that with Chrome. So it's running like that, right? However often you want to run the test out your web page performance. Maybe you want to do a once-a-day snapshot. Maybe you want to do a pre-post release, whatever you want to do, right? Okay, so now there's a lot of other options out there available for capturing that transaction and playing it back. We talked a little bit about WebDriver, which they call it the collection of language-specific bindings to drive the browser. Let's see, it's got a lot of languages available. HP Watch, if you want to use that, it's a really nice tool. It's got some automation you can use on Windows. We've got the website there that you can do. Water is a web application testing in Ruby. It says it's ideal now on Windows, but you can hook them to other browsers via WebDriver using Water. Any of you use Water? Okay. Then there was a presentation yesterday on Capybara. So you can look for the slides on that. It can drive Selenium, but it's more for incorporating a web performance testing component into a larger testing automation framework. Okay, so now once we've got that transaction recorded and running, we want to capture the results, and that's where HAR comes into place. HAR is a portable textual representation of web performance data. You think of that waterfall chart we looked at, basically turn that into text and you've got HAR. It's JSON formatted, so it's really easy to work with. In fact, I've got a sample here I'll show you. So here's a HAR file. It's just it tells you the version of the HAR spec. GCC archive is what that stands for. Which tool created it, what browser it was generated in, just the generic pages. When we started the test, the title of the page that we're learning, and then the title, the page timings for that page load. So, if you have multiple, this is just a single page load in this HAR file. If you have multiple pages, you'd have multiple entries in this pages array. Each one would have start time, an ID, a title that fetches that out of the title element of your page. And then you have page timings, and it can tell you when the content load identifier and the onload identifier. Okay. Now down here in entries, you have individual information about the individual request that made up that page. You have a reference that takes you back to what page it refers to, when that entry started, the method, the URL that it hit, version, any cookies that were in play, and then any headers, the headers that you sent out HTTP request, and then the response headers that came back as part of that. Right? Any query string, any size, body size, and here's the response to that. You had status 200, it was okay. Yeah, HTTP version 1.1. Here are the headers that came back as part of that date, server expired by, et cetera, et cetera, et cetera. Okay, so it's basically just a text representation with a little bit more with the header information, which is always really useful for debugging. So just a useful file format. There's a lot of tools that support it. If you're interested in this kind of thing, have a look. Steve Souders has created this thing called the HTTP archive. Let me open that here real quick. Basically what he's done is he started out with like the 11th up top, 10,000 sites or something like that, and then he repeatedly hits them on a scheduled basis and gathers all of this data in, I assume, HAR format, and shows it in a database and makes it available to look. Possible we quit connections now.
Your 39 minutes are up, have to be reloaded.
Another quarter in the jukebox, right? Okay. Let's see. Yeah. Anyways, had this been a real one. So basically what he's done is he's taken all that data. So you can go, and it's possible your website's in there too. And if not, you can add it to it. And so it goes and fetches that data.
Oh man, it's a lot worse.
Okay. So you can go look at representative samples of all these websites. So you can see, what performance of Yahoo.com has been like over time. You go look and inspect those hard files that they've been generating. Look at the waterfall charts. You can look at all sorts of other interesting data. So go put your site in there, and they'll do it for you. Right? And if you want, it's an open source tool. You can create your own instance of it. We've got the schema and the code that you use to make your own things there. That's pretty useful. There's a lot of tools that export and work with har. I'm not going to do the harviewer demo. Harviewer is a Ruby module that you can install har. You can harviewer. And basically, it can take that har file that we looked at and show you a really nice graphic representation of the waterfall chart and show you the response and request headers, all that kind of stuff. So we'll just skip over that since we're all short of time. So anyways, we want to capture those results in har. So to do that in Firefox, you need to install Firebug, and you want to make sure that Firebug opens, especially if you're going to be automating this, you want to make sure that Firebug opens when you go to the website that you're trying to test. You want to do that inside that clean profile that you created. So you open up that profile, you install Firebug, install NetExport, and then make sure that Firebug pops up when you go to that website, which is kind of good behavior once you turn it on. Then you want to install NetExport as well. There's a couple options in there we'll look at. You want to make sure that you said there's a default log directory where you're going to drop the har files. You've got an auto export that you want to turn on, which says drop in a har file for every page load that you do. Since you get one of those files, you probably want to, as you automate this, you get a har file for every page load in this way. So you may want to create a directory for each invocation of your test to say, here was the test at this time, or whatever conditions you had in place in your profiles you want to do that. Then some gotchas with NetExport, you've got to be careful of when it says this page load is done, I'm going to drop the har file. So sometimes you may have to put, depending on the transaction, I may have to put a dummy page at the beginning of the transaction or at the end to capture the event that you're interested in. Then you can always automate your export dir and what other preferences you want by editing your press.js. So let's have a look at Firefox here, although without internet, that won't work so well. Anyways, you can bring up Firebugs here. Here's your export. This comes when you install the NetExport panel. You want to go into options. You want to auto export. It's going to turn green. And set your default log directory to whatever you want it to be, and that's where it's going to drop the har file. So, how this internet been working? You've been able to see. Let's see. For every page load, you would get one of these zip files, right? So you go from there. You got the har file that we looked at earlier. So every page load. So once you have Selenium running, it's running Firefox. Inside your clean profile, you've got Firebug set to open on that page. Basically, just go to that page, you turn on Firebug, and then every time you go to that page after that, Firebug opens. Okay? And then make sure the NetExport add-in is installed, set it to auto export, and have your export directory set. And so now, let's see. So now, let's say you want to introduce some network latency to see what's this going to look like if we're going to add 10 milliseconds of latency. For whatever reason, right? You want to simulate a data center move. What's going to happen if we add that? Maybe simulate 4 network conditions. And this tool is really rather flexible. I'm going to scratch the surface of it here. If you want to add, for example, this works it's only on Linux. There may be other options on Windows and Mac. I'm not sure. Anyways, if you want to add 100 milliseconds delay to all outbound packets, it's this. And we use this traffic controller. Qdiscipline add to device E0. This little thing here, netem, a delay of 100 milliseconds, and then this turns it off. There's a whole bunch of stuff you can do with netem. You can simulate packet loss, packet duplication, packet corruption, packet reordering, and parentheses. But it requires root access, so you want to make sure that you judiciously use sudo to give whatever user is running all this access to do that. We'll do a demo, but I don't have network access. So basically, it looks like this. You can have a simple script that kind of automates all of this, right? So you add your network delay. You munge the export directory in your press.js with a little Perl invocation, referencing the profile of the clean Firefox profile you created. run the Selenium test script that we generated in the IDE. It'll contact the Selenium server, pop up Firefox with your profile, run through your transaction, which with NetExport will drop the har file so you can have that for analysis, and then kill that extra delay that you added. You don't want to live life at 100 milliseconds to latency. Okay, so now, once we've got that, we've got a whole bunch of har files that we're generating. What do we do with it all, right? Well, you use Perl or whatever else can talk JSON, right? There's a nice Perl archive har module that's out there. For Ruby, there's one called har, JMSL har. There's a Python har, whatever else reads har. Basically, you want to spit out some data which can then be consumed by R or whatever other analysis tool that you're using. Or if you want a good open source project, we make an R module to drop har. I haven't seen one. There is one that can read JSON, but it's one that can drop har, so that would be kind of cool. Here's a sample Perl script. I had to modify archive har just slightly because I was running into UTF-8 issues and it didn't want to parse the har files that I was generating. So, not sure why that is, but just be forewarned. So anyways, we use archive har. We're using Perl slurp to slurp in the har file. I want to print out a header row that R will use in generating its data frame. I'm going to grab the page name, the timestamp that we did it, and then the response time. And I'm going to loop through that har file. I'm going to print out a data row that corresponds to the header for each page, or for each har file that we generated for each page. So I open up I can pass in a whole bunch of files on the command line, start those all in. I'm going to create a new archive har object for each one of those. I'm going to set the string that it's expecting as the har string, or the JSON object, right? As a slurp of the file, and insert the file into memory. And then I'm going to loop through the set of pages in that har file. So the har file may have multiple pages depending on what the transaction looks like. And then I'm going to print out a comma delimited, just like that, the title of the page, the timestamp, and then the response time. So inside your pages array, you're going to have a set of page timings, and the onload, if you remember seeing that inside the har file. So that's what we're doing there. So now you end up with a file that looks like this. So we have the name of the page over here, timestamp of when it was fetched, and then you got to make sure, I think R could probably drop that timestamp, and then you have your response time in milliseconds. You can get so now we go pull that into R. How many of you are familiar with R? R is a really, really nice tool. It's actually an open source implementation of an older language called S. It's a very useful tool for is targeted mainly for statistical analysis. So you can do, and kind of like Perl, its real strength is there's a huge archive of different modules and packages that you can bring into R that can do all sorts of amazing things. You can read XML, you can read JSON, you can read web data, you can run all sorts of stuff. If you want to get kind of a good overview of just kind of what you can do with R, O'Reilly's got a little one of the, it's a PDF you can download. It's like 25 pages. What is it called? Look up all the O'Reilly R books, and it basically takes you through all sorts of open data sets that the guy has pulled in and munched with R, and he spits out some really cool graphs. So, anyways, this is a good book. If you're new to programming, it's probably going to be a pretty steep learning curve. If you've experienced with programming, it'll be a pretty good feature with R. There's a whole series of books by Springer called Use R, the Use R series, and they have all sorts of different topics in using R. The green being one. But then there's also all sorts of free books online to give about R. It's really cool. So basically what we're going to do is load the data into a data frame. It's kind of like a table. And we're going to make a pretty graph. You can do statistical analysis of it over time. Or if you don't want to use R, you know, plug this into whatever visualization tool you like, T3, processing, cloud rate, like was on the last session, Flash or whatever. That's what Flash and I work with over here. So here's a sample R script that I put together last night. So again, we're looking, page, timestamp, response time. I read that page data, create this page data object up here. It gets the output of the read.csv, so I'm using the CSV module to read comma-separated input. This is the file I'm going to spit out to, or I'm going to look at, I'm going to pull in, and it's separated by commas. There's a lot of other options you can do there. You can pull data in just from about anywhere into R. You can do some statistical analysis on this. Basically says, okay, my page data object in my response time variable. This tells me what the minimum value was, the first quartile, the median, the mean, third quartile, max. basic statistics summary. And then I'm going to make a box percentile plot. You can do bar charts, you can do box plots, you can do scatter charts, you can do any kind of chart you want to. And it's a programming language, so really you can just try anything you want.
That's a quick question. Is the
Yeah.
negative one on the min mean it just didn't have a data value to pull in?
Yeah, that's what I meant. Probably what happened there is I interrupted the browser before it finished the unload. Right, like started a new navigation. I think that's what happened. It was being a little impatient, trying to generate a quick data set to generate this. So I'm going to create a box percentile plot, and I'm going to use this page data array that I loaded stuff in. And this construct here says I'm going to create a slice of that data where the page value is equivalent to that, the page name. So I'm going to get a slice of that data where the page is this. I'm going to create several of those, right? And in each of those, I'm interested just in the response time variable in that set of rows. Does that make sense? This is kind of what this means. And then I'm going to divide that by 1,000 to give me seconds. And then some things to make the graph a little bit prettier. I want the names of these page variables I'm creating about, volunteer, contact. I want my X label, the label of my X axis to be page. I want the label of my Y axis to be response time in seconds. And when you get that, you end up with this. So we have our about page, we have our volunteer page, and our contact page. And the box percentile plot works. It basically is like a box plot, but it gives you a better idea of the distribution of your data. So this middle line is your mean. You have your quartiles here, and then the width of that shows you the distribution of how many measurements inside your data set fell into that range. So we can see, most of them are hanging down here 1 to 2 seconds. The contact page could use a little help because it's getting up into the 2-second range. This is only like 25 measurements, so it's a really small data set. You can treat anything in a data set like that. Anyways, that's where you go. So you got the whole stack, yeah.
Sorry, is this a PDF that it's created from R?
This was a ping file. But you can create PDFs, you can create GIFs, you can create all sorts of stuff. Like you can read just about anything. I'm sure there's modules that let you write just about anything. So, next steps on this kind of thing, you've got world domination going, you've got your transactions running, you're capturing the hard data, you're analyzing it, you're making pretty graphs, and your management's happy with all of that. What do you do next? Well, put this in the cloud. Go throw it on Amazon in all the different locations, and hey, you've got 4-man keynote to go next, right? Anyways, you can store your data in a central location on Amazon through a harviewer or an HTTP archive instance in front of it to visualize it, whatever that's what you want to do. And there you go. You've got global diversity measuring, automated web performance analysis. So that's it. Slides will be available here. That's how you can get a hold of me. I'd be happy to answer any questions. Any questions before we're done? Hopefully this has given you something that's of use. Thank you. Yeah, question back here.
Yeah, I developed a web application that's over a RESTful interface, so Selenium obviously wouldn't drive that. What would be a good alternative to replace Selenium to get out the hard output?
So you have like a front-end client that talks to a REST interface to do all the back-end stuff, or?
We just expose RESTful services for other things in our company to consume, but we obviously want to test our performance and
Sure.
see how good we are.
Okay, so probably what I do in that circumstance is I would use whatever language you're programming in probably has some kind of HTTP libraries, right, where I can make requests.
Right.
I would pick a set of representative requests that exercise stuff on the back end that you're interested in measuring. Maybe figure out just ask yourself in your question in your business, what are your key performance indicators, right? What things tell me that my business is healthy and growing? Measure that, right? And so create a set of, maybe it's not Selenium, maybe it's just a script that's making HTTP requests that exercise that functionality. And how you would drop, but in that case, you're not dealing with waterfall charts unless it's just individual requests, right?
Right.
So you probably want to use in whatever library you've got. Like I know Python, in the curl library, you can get timings. I can get connect time, you can get DNS time, SSL time, and all those things. So I would be making requests like that, automated, so they're running on a regular interval, and I'd be looking at those timings for each of those requests, and then just harvest that data. So it probably wouldn't be hard format. Does that make sense?
Right. And what did you say it was that gives you the information on the DNS and all that?
The libcurl.
Okay.
libcurl, which has bindings for a lot of languages. So if you're just making single HTTP requests and not full page requests, then it's a little bit easier. And so if you use libcurl, they can give you those timings. So you get a start time, time to make your speed connection, time to do your DNS lookup, all that kind of stuff. Yeah. Other questions? Cool, thanks.